Prepare the workplace for plasmapheresis. The extracorporeal circuit should be assembled under aseptic conditions. The ECC should be assembled under aseptic conditions. Check integrity of the pack with the lines and plasma filter, as well as the expiration date. Open the packs and lay out the lines and the plasma filter on the assembly table. Lay out the lines around the apparatus, remove the protective cover from pump compartment and insert pump in the receptacle so that the fitting would be located to the left from it. Put the protective cover back. Open the cap of the left electromagnetic valve and fix in it blood draw line, physiologic saline supply line and anticoagulant supply line. Close the cap of the left electromagnetic valve. Open the cap of the right electromagnetic valve and fix in it line for transporting blood to the plasma filter with branching leading to pressure gauge, and secure the expansion pipe vertically in directing slots. Secure the elastic dosing bag in the required slot of its installation unit. So that the segment of line passing from the left electromagnetic valve would be positioned above the slot. Pass the other segment of the physiologic saline supply line through the right electromagnetic valve and connect it to the dropper. Secure the dropper for the physiologic saline at the support stand for the filter holder and close the adjustable clamp. Insert the air trap with an ultrasound sensor in it, the middle area of which should be preliminary greased outside with Vaseline or lanolin, into the circular socket of filter holder. Close the clamp on the air removal line and the clamp after the air trap. Secure the line going from the air trap in two directing slots located at either side of air sensor and check whether the pipe is firmly attached to the sensor. Close the clamp on the blood draw line. Close the clamp on the plasma collection line. Secure it in the right electromagnetic valve. Close the cap and connect to the plasma accumulation reservoir. Secure the hook on the digital spring balance. Insert the plasma filter into the corresponding slot of the filter holder so that the joining pipe, designated as in red cap, would be attached from beneath as to make blood flow bottom up, a feature that provides for the reliable removal of air from the plasma filter. Remove the protective caps from the joining pipes of the plasma filter. The line with the red joining pipe is connected to the joining pipe designated as in red cap, while the line with the blue joining pipe is connected to the joining pipe designated as out, blue cap. So as to transport formed cellular blood elements from the plasma filter into the air trap. The joining pipe of the line should be connected to the plasma out outlet, white cap. Check whether all the clamps of the system of lines are closed. Proceed with the filling of the extracorporeal circuit. Remove the protective cap from the needle of the dropper and insert it into the anticoagulant reservoir and suspend the reservoir on the right hook at the support stand. After which, fill the dropper to half its volume. Remove the protective cap from the needle of the dropper and insert it into the physiologic saline reservoir. And suspend the reservoir at the left hook at the support stand, after which fill the dropper to half its volume. Attach the infusion needle to the infusion unit, supplied together the set of lines, and connect to the physiologic saline reservoir. This finishes the assembling of the extracorporeal circuit. Filling the extracorporeal circuit. Remove the cap from the air trap and open the clamp on this line. Open the adjustable clamp to allow the anticoagulant to fill the line. As soon as the anticoagulant appears in the pump, the adjustable clamp should be closed. The adjustable clamp on the physiologic saline line should be opened to fill the line. As soon as physiologic saline reaches the pump, the clamp should be closed. Open the clamps under the air trap and on the blood draw line. Remove the air in the blood draw line and lift the right side of the pump without withdrawing it completely, so as to continue the filling of the extracorporeal circuit with physiologic saline. Once the pump is filled, the pump should be lowered into the pump compartment, while continuing filling until the air trap is full. After which, the clamps on the air line should be closed. put the protective cover back. Switch on the apparatus by flipping the main switch into position 1. The display should flash Track Poor Technology, while left LED should light up red. Push the start button and continue filling the extracorporeal circuit with physiologic saline so as to displace air from all its segments. To completely remove the air from the pump, it is necessary to lift its right side. To perform the same operation for the air trap, it is necessary to close the clamp on the air trap and open the clamp on the air line, and wait until the liquid appears from the trap's joining pipe, after which the clamp on the air line should be closed, while the clamp on the air trap opened. After checking that the extracorporeal circuit is filled completely, push the stop button. Make sure that no air is present in the pump. Push the procedure pumping button. The apparatus is switched to the procedure mode, in which both the air sensors are working. Push the start button and work in this mode 5 to 10 minutes. Open the clamp on the efferent plasma line. Remove the air from the plasma line and close the clamp again. Push the stop button, then the reset button. Check the closing of all the clamps. The apparatus is ready. So the device is ready and the patient is here. We put the cuff of the blood pressure monitor on. The puncture site over the cubital vein is cleansed with a disinfectant. We take a catheter catheterize the peripheral cubital vein, remove the infusion set needle from the bottle that contains normal saline, remove the needle and connect the infusion set to this catheter. Fix the catheter with adhesive plaster. Infuse heparin, 2/3 of the total dose, which is 150 units per kilogram body weight, into the port of this catheter. The device is now ready for the procedure. We turn it into the procedure regime. In this regime, the entire safety system is on. We unclamp the anticoagulant line. The sodium chloride solution is not fed. We unclamp both lines of blood drawing and returning. Increase the pressure in the cuff to 20-30 millimeters of the mercury and turn the device on. Blood drawn through the venous catheter is under control. Air bubbles appearing in the trap should now be removed. We're waiting until the plasma filter is filled with blood. Ready. The efferent plasma line can now be unclamped. We open the clamp on the efferent plasma line. You can see plasma flowing into the plasma collection reservoir. Plasma volume is controlled by the electronic balance. This is the blood drawing line. Blood flows through the pump, enters the plasma filter, then passes the trap and reaches the blood returning line. Now we put the blood returning line into the slot of this chamber, designed to irradiate blood with red laser light. And turn this device on. Red light can be seen through the slot. That's blood being irradiated on the returning line. This is absolutely crucial in order to carry out immunocorrection directed at the immune system. In the blood returning phase, the right indicator is alight. The necessary volume of anticoagulant flowing out can be observed as a trickle in the filter. Now this trickle can be seen. This is the anticoagulant dose needed for one operation cycle. If the patient's blood is very concentrated, the amount of erythrocytes is above normal, we can add in some sodium chloride solution, 3 or 4 drops, during blood drawing. We can control how the device is working. We press the indicator button. Now we check the set pressure, 150 millimeters of the mercury. The current pressure is around 150 as well. This means all goes well. We press the indicator button once again and get the working time, 5 minutes. In this period, 300 millimeters of blood have passed through, and we got approximately 130, 140 milliliters of plasma out of that volume. This plasma is absolutely pure, without any formed elements mixed in. It is just like donor plasma, and it completely meets the blood service requirements. We press this button one more time and go back to the blood drawing and returning time control regime. The times of blood returning and drawing are alternating here. Then we control the operation of the entire system by these parameters: the times of blood drawing and blood returning. If the drawing line is on the increase, we check the condition of the vein and the drawing speed. If this time is insufficient, we will increase the pressure inside the tonometer cuff to 30 millimeters of the mercury. In order to increase somewhat the dose of the anticoagulant, we can put its bag higher, so the anticoagulant dose will be a bit increased. If the blood returning time is on the increase, the membrane pressure of the filter should be enhanced. We stop the device, press the programming button, then press the set pressure increasing button. You can see 150, 165, 170. Let's stop, for example, at 195 millimeters of the mercury. Then we press consecutively the programming button and the start button, and the device will start working at this higher pressure. And now it is working rather faster. Returning takes 6 seconds instead of 10 seconds earlier. And this pressure increment has not affected quality of plasma in any way. It is still pure, cell-free. So the plasmapheresis procedure has come to an end. We have collected 770 milliliters of plasma filtrate, and thus we take the additional pressure off the tonometer cuff. Clamp the blood-drawing line, open the normal saline feeding line, shut the anticoagulant feed, and as soon as we see that the blood on the blood feeding line has been diluted, we shut the plasma collection line. Thus we have collected a good volume of normal plasma. Now replace the taken volume with the sodium chloride solution left in this bag. In this way, we have displaced all patient's blood that was inside the device. Now the device can be stopped. But let us see how the safety system works and stops the operation on its own. The expelled air can be seen. Here it goes inside the trap, reaches the ultrasonic sensor, and the device is turned off. The display reads, breakdown, device stopped, air bubbles in the trap. And this is the safety measure. We shut the returning line. So we have completed the whole task. We remove the catheter out of the vein and apply a compressive dressing. Take the tonometer cuff off. So we have put the compressive dressing on and can now consider the procedure finished. Let's measure the blood pressure on the other arm. It's 120 and 70. The patient feels good. That's all. Our patient can get up. As you just could see, this plasmapheresis procedure is over. It went unruffled, normal, and without any complications. Its simplicity and safety make it fully meet all